Introducing GAIO Technology's Safilia tool suite, meeting the challenges and presenting solutions in the field of safety design. Today we are going to discuss some of the challenges of safety design and some of the methods that exist to deal with those challenges. We will demonstrate how the Safilia tool helps in the process of safety design, from the initial model design through the conception, implementation, and testing to help solve some of the development challenges faced. In the first section, we will describe the main features of safety development and the ways to meet those requirements. Safety development in the automotive industry is governed by the ISO standard 26262. This defines the safety design requirements for the entire development process. The main points of these requirements are confirmation of suitability and robustness, safety level decomposition and safety level based development, validation and verification, documentation, planning and execution, audit and assessment, assignment of responsibilities, and collaboration to achieve goals. In order to achieve these goals, several things are considered necessary: a means of defining and agreeing upon the requirements and the philosophy behind them, a means of reviewing the designs, the tests developed for those designs, and the results of those tests, a clear definition of the roles of developer and assessor, and a well-defined organizational structure to ensure the responsibilities of each role are fulfilled. This diagram shows how an organization should be structured to implement safety development effectively. Safety development should be carried out in parallel to other functional development, so that the safety measures decided upon in the safety development are reflected in the design of the functional development. Equally, the protection mechanisms of the safety development should ensure that any faults that exist in the functional development do not interfere in the correct operation of the safety aspects of the design. Close cooperation and interaction between these departments is also essential. The engineering department responsible for the project will be subject to both assessment by the functional department responsible for overall assessment of functional safety, as well as receiving audits from the quality department. So it is obvious that a means of communication is necessary between the involved parties, which allows aspects of safety design to be clearly and comprehensively described and shared. We will now show how Safilia can help in this regard. Safilia can be used in practically all of the activities necessary for safety development. This means that Safilia can be the one unified tool needed to cover the entire process. The safety concept description language is a means of explaining safety concepts and designs in an easy-to-understand, standardized format. Safilia also supports safety design requirements and concepts such as FMEA and FTA. Hazards and risks and their countermeasures can be identified, described, and traced easily. Without such a tool, descriptions are haphazard and can vary with the author's skills and preferences. Safilia allows a clear link between each requirement of the safety concept and the results of the safety analysis which implement it. This enables clear and effective discussion of the safety concept during reviews and assessments. Safilia also facilitates efficient, methodical ASIL decomposition of requirements, ensuring that a clear link exists between each requirement and its decomposition result. The highlight function of Safilia allows clear focus on specific topics during reviews, helping to identify omissions in scope and other problems. Other methods of review presentation rely on manual operations which are prone to mistakes and thus reduce efficiency. Safilia also allows a clear and consistent relationship between safety concept requirements and the test cases generated to ensure their effective implementation. This allows quick confirmation that requirements are sufficiently tested, which will save time during test plan reviews. Safilia is capable of this kind of relationship tracking throughout the development process, from requirements to analysis results to test cases and test results. Additions and alterations to the safety development plan can also be traced quickly and easily to the changes made to the product to accommodate them. The Safety Development Results View allows clear and easy confirmation of the integrity of the development process, showing clearly the linkage between requirements and results. This helps the audit assessment stage of the process go smoothly compared to projects that do not use Safilia. Results can be shared within the organization in a controlled way if necessary, using Safilia's redaction function to restrict access to portions of the results on a case-by-case basis. Without Safilia, this would have to be done manually for each situation. Similarly, Safilia allows for multi-path management of the design results, allowing security, safety and function development to progress independently before being merged together again through the differential management of the sysml files used to describe the design results. Thus, the use of Safilia can lead to reductions in the workload for many stages of the design process and a much more robust design process overall through the efficient sharing of information and the effective validation of each step of functional safety development. Safilia makes use of the safety concept description language. Let's find out a little more about that. In this section, we will learn about what SCDL is, how it compares to other notation methods, and how it interacts with sysml, the system modeling language. SCDL is a graphics-based means of representing functional and engineering concepts in an easily understandable way. This standard was created by the Safety Concept Notation Study Group, an industry body comprising car manufacturers and suppliers. There are other notation methods in use, but since these are not designed specifically for safety concept description, they lack certain features and attributes that are present in SCDL. SCDL is designed to describe the safety concept as a model, so it is not just a diagram, but each attribute and component has a meaning attached. This prevents inconsistent or ambiguous information from being included in the description and helps to eliminate errors of comprehension. SCDL also has descriptors for ASIL assignments, so the decomposition process can be clearly followed, and Safilia automatically assigns ASIL levels to requirements and elements to avoid errors. sysml and other notation systems do not have a means of expressing a non-interference relationship between elements, so users must devise one for themselves. If this is incorrectly understood by others assessing the document, there will be an unnecessary time loss in reviews and other occasions where this must be explained. SCDL has specific notation for non-interference and so can avoid this kind of problem. Incorrect assignment of ASIL levels can also be avoided in such cases. So the main merits of SCDL are that it allows explanation, review and approval of safety documents even by those without specialty training through its easy to understand format and structure. And because it has built-in features to handle safety concepts, it can also help prevent errors and omissions in safety design. Tools can be designed to automatically check for violations or inconsistencies in the content of documentation. Further, SCDL is particularly suited to describing model-based systems. The requirements, behavior, and structure of the system can be maintained throughout the model and traced across processes within the model. Finally, compared to generic modeling languages such as sysml, SCDL is easier to use and better capable of describing safety-based system requirements. Next, let's take a look at some features of the Safilia tool itself. We will begin with the concept of Safilia and how it is used, then move on to its structure and future expansion before taking a look at some of its main functions. Safilia is designed to help create safety concepts smoothly, from describing safety requirements and assigning them to elements which will implement them, to validating those requirements and coordinating the management of all the information generated about them. This diagram shows how the Safilia tool is used in the development process. Sections marked in green here are the parts of the development process that can benefit from the use of Safilia. Two of the main components of the Safilia tool are shown here. The designer is used to create specifications for the architecture and elements, while the integrator allows these specifications to interface with external documents and tools. Each of these main components also has several optional features which are covered by separate licenses. For designer, there is the safety concept analysis option, which allows additional analysis functions, and the design pattern option, which allows efficient reuse of design resources in other projects. For the integrator component, there is the binder option, which enables sysml-based design data to be merged with SCDL-based safety design data, and the requirement management interface option, which provides a convenient interface to requirement management tools such as doors. Two of the main components of the Safilia tool are shown here. The designer is used to create specifications for the architecture and elements, while the integrator allows those specifications to interface with external documents and tools. Requirement architecture notation is a means for describing the relationship between safety requirements and the interaction and interdependence between them. Element architecture notation defines element inclusion, how the elements are grouped into subsets in order to realize the requirements. This helps to visualize the requirement architecture and the scope of each ASIL level. Safety requirement and element assignment notation helps to clarify the mapping of ASIL levels to elements, as well as assigning the safety requirements to those elements. Safilia automatically assigns to each element the highest ASIL from among all the requirements assigned to that element. Safilia also has several features to aid in the description of ASIL decomposition. Requirement grouping and independence are represented graphically to be easily and quickly understood. The freedom from interference between elements is also represented in notation, allowing the diagrams to clearly show independence between functions. The description of interfaces between requirements is also important to show how those requirements interact with each other, as well as to connections outside the system. Various types of safety analysis can be carried out easily using the graphical description properties of SCDL, as well as organized lists of function elements. The ability to highlight relationships between safety analysis and SCDL components makes explanation during reviews much easier. It is also possible to link SysML model data to SCDL data. SysML data created by tools such as Enterprise Architect can be imported into Safilia for use in the design and safety analysis. An example of this is shown here, where a SysML internal block diagram is imported into a safety concept diagram. And here we have an SCDL diagram exported to SysML data. The fault chain display function allows graphical representation of the results of safety analysis and FMEA analysis, which can be imported in CSV format. Portraying these results in the SCDL format enables clear explanation so that omissions and mistakes can be detected easily. Here is an example of a fault chain. The graphical representation allows easy identification of the connection from the part failure to the safety objective being breached. Since the connections in the fault chain are stored in the visualization, selecting a fault in the FMEA results causes Safilia to highlight the same fault in the safety concept diagram. Highlighting like this makes it easier to follow the explanation during a review. Safilia uses the XML specification as a basis for the SCDL format, so it is possible for files to be imported and exported from Safilia in this way. And from version R3 onwards, Safilia uses the CSV format so files can be manipulated using more powerful tools like Excel. Elements can also be exported. In order to share these with other departments to whom it may not be possible to disclose the full details, Safilia offers the option of anonymizing them, so you get to select what information is exported. Safilia also has the ability to use design patterns. These are predefined blocks commonly used in safety designs that can be inserted into design specifications. Since they have been previously used and verified, they can be used easily and with confidence. The 5 patterns implemented, which are shown here, are among a total of 15 patterns defined by the JASPAR organization. These design patterns combine the safety mechanism and intended functionality into a single entity, if the safety analysis determines this to be necessary. Thus, the design patterns can be used without the need for case-specific modification. So merely by selecting the function to which the pattern is to be applied, and the pattern to be used, the safety mechanism is selected automatically and inserted into the function when the pattern is applied. GAIO can also offer helpful support for safety development. Apart from providing our Safilia product to match your needs, we also follow up on this with engineering support, currently available only in Japan, which provides training, consultation and development support based on our rich experience in the field. Lastly, let's take a look at some examples of Safilia at work. Some examples of Safilia being used in ongoing development can show us the benefits of this tool for parallel development of functions and safety. Safety development can be considered to be a secondary process to functional development. However, since the two activities can be executed reasonably independently, development can be carried out serially or in parallel. Serial development is easier to plan and manage, but parallel development allows for shorter development cycles. If development is done in parallel, there must be some means of merging the output of both development processes. The complexity of this merging depends on the tool used, with purpose-designed tools providing a smoother merge operation than generic software such as Visio. Safilia includes checks for undefined elements in the safety design and automatically merges these with the functional design. So, what have we learned today? We have seen that Safilia can be of great benefit to safety development. We have seen how it can enable safety development to progress in parallel to function development, how it can help improve the effectiveness and efficiency of safety development reviews and the entire safety development process, and we have shown how SCDL is a superior means of safety concept description. More information on the full range of tools from GAIO Technology can be found on our website. Thank you for your time and attention.